Welcome to Unit 2, Lesson 22. This is the second part of graphing linear inequalities in two variables. In today's lesson, we're going to write inequalities in two variables and make sense of the solutions by reasoning and by graphing. We have three learning targets today. The first, given a two-variable inequality that represents a situation, you should be able to interpret points in the coordinate plane and decide if they are solutions to the inequality. Number two, you should be able to find the solutions to a two-variable inequality by using the graph of a related two-variable equation. And number three, you should be able to write inequalities to describe the constraints in a situation. Our warm-up today is 22.1, landscaping options. A homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in other parts. Grass sod installation costs $2 per square foot, and flower bed installation costs $12 per square foot. Her budget for the project is $3,000. Number one, write an equation that represents the square feet of grass sod using X and the square feet of flower beds using Y that she could afford if she used her entire budget. So we know that grass sod is $2 per square foot, and we know that grass sod is X. So that would be 2X. That's going to give us the total cost of the grass sod. We also know that flower bed installation is $12 per square foot. And we know that flower beds are Y. So that would be 12Y. That is going to give me the total cost of flower bed installation. So what we're going to do is we're going to add the cost of the grass sod to the cost of the flower bed installation, and that needs to be less than or equal to the budget of $3,000. You can spend less than $3,000, or you can spend right at $3,000. They wanted the equation though, so now we're saying she wants to spend specifically right at the $3,000 budget. So when we graph this, we're going to have a line. In order to do this, we have X plus Y equals something. This is standard form. And standard form is great for finding the X and Y intercepts. First, I can say that X is 0. Anything times 0 is 0. Divide both sides by 12 to get Y by itself. And you find out that when X is 0, Y equals 250. So I can put my Y-intercept right here. I can find my X-intercept by setting Y equal to 0. Anything times 0 is 0. So 2X equals 3,000. Divide both sides by 2 to get X by itself. And we find out that when Y is 0, X equals 1,500. We can put our X-intercept right here. And then we draw a straight line to connect these 2 points. All the points on this line are combinations of x and y that will equal 3,000. In this situation, what does a point on the line mean? It means it'll make the left side equal 3,000. What does the vertical intercept of the graph mean? That means if we install no grass sod, we can install 250 square feet of flower beds. What does the horizontal intercept of the graph tell us? It tells us that if we install no flower beds, we can install 1,500 square feet of grass sod. Our next activity is 22.2, titled Rethinking Landscaping. The homeowner is worried about the work needed to maintain a grass lawn and flower beds, so she is now looking at some low-maintenance materials. She is considering artificial turf, which costs $15 per square foot to install, and gravel, which costs $3 per square foot. She may use a combination of the two materials in different parts of the yard. Her budget is still $3,000. On the previous slide, they give us a graph representing some constraints in this situation. The graph shows a line going through the point 500, 100. In this situation, what does the point 500, 100 mean? 500 is our x, so that means 500 square feet of gravel. The 100 is our y value, so that means 100 square feet of artificial turf. They want us to write an equation that the line represents. So they told us gravel is $3 per square foot, and gravel is on our x-axis. So we would write 3x. This gives us the total cost of the gravel. They told us artificial turf costs $15 per square foot, and that is on our y-axis. So that would be 15y. And that gives us the total cost of artificial turf. Now, if we add the cost of the gravel plus the cost of the artificial turf, that would equal the $3,000 budget. So this would be the equation that represents the line. What do the solutions to the equation mean? This is every combination of gravel and artificial turf that equals exactly $3,000. So now they want us to look at the point 600, 200. This point is located to the right and above the line. Does that combination of turf and gravel meet the homeowner's constraints? So that would be 3 times 600 plus 15 times 200. 3 times 600 is 1,800. 15 times 200 is 3,000. And 1,800 plus 3,000 equals 4,800. This is more than the budget, so it does not meet the constraints. So now they want us to choose another point in the same region and check to see if this combination meets the homeowner's constraints. So we can pick any point out here, such as 1,100. So we can say 3 times 1,000 plus 15 times 1 times 100. 3 times 1,000 is 3,000. 15 times 100 is 1,500. And 3,000 times 1,500 is 4,500. Again, this does not meet the constraints because this is over budget. Now they want us to look at the point 200, 100 that is located to the left and below the line. Does that combination of turf and gravel meet the homeowner's constraints? So now we would say 3 times 200 plus 15 times 100. 3 times 200 is 600. 15 times 100 is 1,500. And 600 times 1,500 is 2,100. That does meet the homeowner's constraints because it comes in under budget. Now they want us to choose another point in the same region. So if we look, we could choose a number such as 250. So if we try that point, we have 3 times 200 plus 15 times 50. 3 times 200 is 600. 15 times 50 is 750. And 600 plus 750 is 1,350. Again, this does meet the homeowner's constraints because it's less than the budget. Now they want us to write an inequality that represents the constraints in this situation, explain what the solutions mean, and show the solution region on the graph. So, when we talk about a budget, you can spend less than the budget or you can spend exactly the budget. You just can't spend more than the budget. So this inequality would be 3x plus 15y is less than or equal to 3,000. We have the 3x is the cost of the gravel, 15y is the cost of the artificial turf, and when we add them together, we need to spend $3,000 or less. And if we graph that, we are counting every point on the line because that equals 3,000, and we're counting every point below and to the left of the line because that is less than 3,000. Both 150 and 50/100 are in the solution region. Both points mean a total of 150 square feet of landscape materials. Does it make a difference which option is chosen? Because they are both in the solution region, it does not make a difference which option is chosen. They will equal different amounts, but both amounts come in under budget, so you still have enough money to pay for either one. All the points in the shaded region represent amounts of gravel and turf that are within the homeowner's budget. Are all these options equally good and desirable? It depends on the homeowner's preference. You could have all gravel, you could have all artificial turf. If you want the whole yard covered, then you would need to come up with a mixture of both that would allow you to get the full coverage and stay under budget. It could depend on your personal belief as to what looks better. So it's going to matter person to person. Our next activity is 22.3, the Saturday market. A vendor at the Saturday market makes $9 profit on each necklace she sells and $5 profit on each bracelet. Find a combination of necklaces and bracelets that she could sell and make exactly $100 profit. Now, looking at the numbers, I know that 5 is an easy number to use to get to $100. 9 is not as easy. So there's only two options that we could mix together here. We could say 5 necklaces and 11 bracelets would equal $100 because that would be $45 plus $55, which would equal 100. Or we could say 10 necklaces and 2 bracelets equals $100 because that would be $90 plus $10, which equals 100. So you either have 9 necklaces and 2 bracelets, or 5 necklaces and 11 bracelets. Those are the two possible combinations. Now they want a combination that makes more than $100 profit. And there's actually an infinite number of possibilities here, because anything greater is going to do just fine. So I could take and add one more to each, and I could say 6 necklaces and 12 bracelets. This combination would be 9 times 6 plus 5 times 12. 9 times 6 is 54. 5 times 12 is 60. And that equals $114. So that's one example of a combination. Now they want us to write an equation whose solution is the combination of necklaces and bracelets she could sell and make exactly $100 profit. So necklaces are $9 each, and we don't know how many. And bracelets are $5 each, and we don't know how many. But we want it to equal exactly $100. So that would be the equation to represent this. Now they want us to write an inequality whose solutions are the combinations of necklaces and bracelets she could sell and make more than $100 profit. Again, necklaces are $9 each, and we don't know how many, plus bracelets are $5 each, and we don't know how many, but now we want to make more than $100. So this would be the inequality that would represent that. Now they want us to graph the solutions to our inequality. So if we go back and look, I said we could do 5 necklaces and 11 bracelets. Which is right about here. And I said we could do 10 necklaces and 2 bracelets. Which would be right about here. Now, they want the solution to the inequality, and the inequality was that we made more than $100 profit. So we don't want to include the numbers on the line. So when we draw this, we're going to use a dashed line to represent it. Then we needed combinations that were going to earn us more money. So we said if we just added a necklace and added a bracelet, then that would come out to be more. So our shaded region is going to be the entire area above and to the right of the dashed line. Every point combination in this green shaded area will earn more than $100 profit. And last, they want to know, is the point 318.6 a solution to the inequality? You actually don't even have to do any math on this one. If you wanted to, you could plug in 3 for x and 18.6 for y and see if it came out to be more than 100. So you could have 9 times 3 plus 5 times 18.6. That would be 27 plus 93, which equals $120. So mathematically, that would be a solution because it's more than $100. But logically, in context, it would not be a solution because you cannot sell zero point 0.6 bracelets. You have to sell whole number bracelets. So while mathematically it would be an answer, it's not a solution because you can't sell partial bracelets. So you can't just stick to the mathematics. You also have to think about the context those mathematics represent. So our next activity is 22.4, titled Charity Concerts. A popular band is trying to raise at least $20,000 for charity by holding multiple concerts at a park. It plans to sell tickets at $25 each. For each 2-hour concert, the band would need to pay the park $1,250 in fees for security, cleaning, and traffic services. The band needs to find the combinations of numbers of tickets sold using T and the number of concerts held using C that would allow it to reach its fundraising goal. And they want us to write an inequality to represent the constraints in this situation. So, if we sell tickets at $25 each, then the amount of money we would raise would be 25 times T. But we have expenses. So we need to subtract $1,250 per concert. And then we need to raise at least $20,000. So that means greater than or equal to 20,000. So this would be the inequality. Now they want us to graph the solutions to the inequality on the coordinate plane. The first thing we could try is if we did one concert, how many tickets would we have to sell? Because if we did no concerts, we wouldn't have any expenses, but we also wouldn't have any ticket sales. So we're going to try 25T minus 1,250 times 1. So 25T minus 1,250. I'm going to add 1,250 to both sides. And I have 25T is greater than or equal to 21,250. And now I'm going to divide both sides by 25 so that I find out how many tickets I would need to sell. The number of tickets would need to be greater than or equal to 850. So I could put my first point right about here. So now we're going to pick a number for tickets. I'm going to use 2,000. 25 times 2,000 minus 1,250C must be greater than or equal to $20,000. 25 times 2,000 is 50,000. I'm going to subtract 50,000 from both sides. I get negative 1,250C must be greater than or equal to negative 30,000. Divide both sides by negative 1,250 so that I can get C by itself. And I find out that C, don't forget to flip the sign when you divide by a negative. C is less than or equal to 24. So I can put another point right here. Now, because I have greater than or equal to, this is going to be a solid line joining these 2 points. And now I need to know, do I shade to the left or do I shade to the right? And an easy one here is if I take the origin 0, 0, then I sell no tickets and I have no concerts. So there's no possible way I could make $20,000. So if the origin won't solve it, then I need the points on the other side. So we are saying the points on the line are solutions because they will earn exactly $20,000 for charity. And all the points in the shaded green area to the right are solutions because it will equal more than 20,000. Now they want us to name 2 possible combinations of numbers of tickets sold and numbers of concerts held that would allow the band to meet its goal. So I could pick any 2 numbers over here. So to make this easy, I will choose 1,500 tickets and 4 concerts. And then a second point pair in that area could be 2,000 tickets and 8 concerts. Which combination of tickets and concerts would mean more money for charity? First, they give us 1,300 tickets and 6 concerts. or 1,300 tickets and 5 concerts. For this one, I don't even have to do any math. If I sell the same number of tickets, then I make the same amount of money. But every concert I have gives me more costs that I have to pay for. So if I have to pay for 10 concerts, that's $12,500. If I only have to pay for 5 concerts, then that's $6,250, and there's more money left over. So for that one, this would be our better combination. And if we look at our graph, 1,300 would be right here. 5 concerts would be here. 10 concerts would be right on the line probably. So the closer we are to this line, the more we're at the 20,000, the more we're in the shaded area, the more we're over 20,000. So that's another way you could look at it. Now they want to know 1,600 tickets and 16 concerts. 1,616 looks like it's on the line, so that would be right about $20,000. Or 1,200 tickets and 9 concerts. 1,200 is here. 9 concerts is above the line in the non-shaded area, so that would be less than 20,000. So for B, our better option is this one. It would make 20,000, whereas the other one would make less than 20,000. And finally, 2,000 tickets and 4 concerts. 2,000 tickets, 4 concerts. We're way out here in the shaded area, so we're making way more than $20,000. Or 2,500 tickets and 10 concerts. So that is also way out here in the shaded area. So we would actually need to mathematically calculate this. So first we have $25 a ticket times 2,000 tickets minus $1,250 times 4 concerts. This is $50,000 in revenue minus $5,000 in costs for a total of $45,000 profit for charity. Now we can try the other combination. That's 2,500 tickets minus the cost of 10 concerts. So this would be $62,500 of revenue minus $12,500 of cost for the concerts, leaving us with $50,000. So the second option gives us more money. So sometimes you can just compare whether points are in the shaded area, on the line, or in the non-shaded area. Other times you might have to actually put in the numbers and calculate it mathematically. So we've come to our lesson synthesis. How are the solution regions of the two inequalities alike? Well, they both include the blue shaded regions. How do we know where the boundary line would be for each graph? We have standard form inequalities here. So if we plug 0 in for the number of necklaces, we can calculate how many bracelets, and we would get 20. And if we put in 0 for the number of bracelets, we could calculate how many necklaces. This would give us our x and y intercepts, and we could draw the lines. Then, for the bottom one, I could put in 0 for gravel, calculate how much artificial turf I could afford. That would give me my y-intercept. Then I could put 0 in for artificial turf, and I could calculate how much gravel I could get. And again, this would give me my x and y intercepts, and then I could use my line to join them. In the first situation, some pairs of values that are in the solution region don't make sense in the situation. Can you explain why a pair such as 801, which is in the solution region, might not be a reasonable option for the homeowner? So when we're looking at this bottom graph, if we had 801, we can see that it is down here in the blue shaded region. But this would mean 800 square feet of gravel and then one little 1 foot by 1 foot piece of artificial turf. And that just doesn't make any sense why you would have one little square of artificial turf and then all of this gravel. So you have to take it in context. In the second situation up here at the top, we know that fractional values are not meaningful even though they are in the shaded region. Can you think of other reasons that some points in the solution region might not make sense? So just because all of these points are in the shaded region doesn't mean that all make sense. In addition to the fractional ones, this shaded region is going to go on to infinity. And if this is one person selling necklaces and bracelets at a Saturday market, there's only so many bracelets that one individual can make and sell, and there's only so many that people are actually going to buy. So there would be some type of limit as to what numbers. We could not go all the way to infinity. Now our cooldown is 22.5, a weekend of games. To raise money for after-school programs at an elementary school, a group of parents is holding a weekend of games in a community center. They charge $8 per person for entry into the event. The group would like to earn at least $600 after paying for the cost of renting the space, which is $40 an hour. If X represents the number of entry tickets sold and Y the hours of space, which inequality represents the constraints in the situation? So what we see are the keywords at least. So they want to make $600 or they want to make more than $600. They just don't want to make less than $600. So the correct solution would be D, because that says when they take the money they earn minus the expenses, they are still left with more than or equal to $600. Number 2, the line is the graph of 8x minus 40y equals 600. Select all points whose XY values represent the group reaching its fundraising goal. Explain or show your reasoning. So an easy way to do this, my favorite point to check is always 0, 0, the origin. Well, if I say 0, they don't sell any tickets. 0, they don't have any expenses. They don't make any money. So that could not possibly be the solution. So A would not be in the solution region either. So the points that could actually be in my solution would be all the points on the line, such as B, because that would earn them exactly $600, or all the points in the shaded region below and to the right of the line, such as C, because all the points in the shaded region would give them more than $600 of profit. We make it a solid line because we did say at least, so $600 does count, and all the points on the line will make exactly $600 profit. So now we want to go back to our learning targets. Number one, if you are given a two-variable inequality that represents a situation, you should be able to interpret points in the coordinate plane and decide if they are solutions to the inequality. If you feel comfortable with this, you're right where you should be. If not, please ask questions so I can give you clarification. Number two, you should be able to find the solutions to a two-variable inequality by using the graph of a related two-variable equation. If you feel comfortable with this, you're right where you should be. Moving forward, if you still have questions, please ask for clarification. And number three, you should be able to write inequalities to describe the constraints in a situation. If you feel comfortable with this, then you are right where you should be moving forward to the next lesson. If not, please ask for clarification. Your next test will be Thursday, November 30th.